In this video, we'll show you how to calculate the signal-to-noise ratio of peaks in the 32-Karat software. Calculating the signal-to-noise ratios of electropherogram peaks is a way of showing how clearly the measures of our analytes stand out from background noise. This ratio helps to determine whether a peak is reliable enough to be used as a real estimate of analyte identity and quantity. This ratio is often used to validate limit of detection and limit of quantification. Typically, the higher a signal-to-noise ratio is for a given peak, the more we can trust that it is a reliable signal and not just background noise. A low signal-to-noise ratio may indicate a poor analyte separation, low sample concentration, or high instrument noise. To calculate the signal-to-noise ratio for each peak, we will ask 32-Karat software to do the following. First, it will overlay the baseline file acquired during the sequence. Then, it calculates the width of 50% height for each integrated peak. This width is multiplied by 20. The software uses this interval in the baseline file to calculate noise. To begin, open the 32-Karat software. Then, load your integrated electropherogram data file for which you'd like to calculate the signal-to-noise ratios. Ensure the data appears as expected and is ready for analysis. Right-click the electropherogram and select Annotations. Make sure Baseline is selected. This enables 32-Karat software to overlay the baseline file that was acquired during the sequence. Then, select Apply to All and click OK. Right-click the electropherogram again and select Add Trace. Click the icon next to Data Source and select Open Data from the drop-down menu. Select the baseline file, which is acquired during the sequence run. Select Apply, then click OK. The blank file will be overlaid onto your open data file. To improve readability of both electropherograms, you will offset the baseline file trace. To do so, right-click the electropherogram and select Operations, then Stack Traces. Enter 0.01 in the y-axis field and click OK. Now, select Method from the top of the screen, then Advanced. Select the Capillary and Performance tab and ensure the Calculate Performance parameters for this channel and the USP box are checked. Close the window. Then, right-click the electropherogram and select Annotations. Under Available Annotations, select Width at 50% height and click the right arrow to move it to the Show the Following Annotations column. Select Apply to All and click OK. Then click the icon to analyze the data. Now, most peaks will be annotated with their width at 50% height. However, you will see that some of the peaks do not have this annotation due to the software's inability to distinguish between peaks with high intersects. There is a workaround for this, which we will discuss later. To continue setting up our calculation, select Method from the top of the screen, then Advanced. Select the Custom Parameters tab. Enter a parameter name and select Per Peak under Type. Then, select Number under Returns. Click the arrow under Source to select a custom parameter file. In the 32-Karat folder, choose the file named signalnoise.dll. Do not use the signalnoise.usp.dll file, even if you are using USP, because it has low accuracy. Click OK. Under Additional Parameters, enter the file path of your baseline data file. Make sure to add the full data file path for the baseline file. Then, select the icon to analyze the data. Right-click the electropherogram and select Annotations again. Scroll to the bottom of the Available Annotations pane and select your recently added custom parameter. Select Apply to All and click OK. Now, you will see that the signal-to-noise ratio is calculated and displayed above peaks for which the width at 50% height was able to be calculated. To show the signal-to-noise ratio for the remaining integrated peaks, you will need to set the software to use a specific segment of your baseline file to calculate the signal-to-noise ratio for those peaks. To do so, select Method from the top of the screen and select Advanced. Navigate to the Custom Parameters tab to add a new parameter. Since you will be using the same baseline file from before, copy and paste your prior custom parameter and add the word segment to create a new parameter. Next, you will specify the segment of time from your baseline file that you would like to use to calculate your signal-to-noise ratio. The chosen segment will be used as the noise interval for all peaks, regardless of their actual 20 times peak width at half-height interval. Under the Additional Parameters column in the row with your new parameter, add a semicolon to the end of the text string, and then a time interval by entering your desired start time, followed by a colon, your desired end time, and another semicolon. Then, click the icon to analyze the data. Right-click the electropherogram and select Annotations again. Scroll to the bottom of the Available Annotations pane and select your recently added custom parameter. Then, click the right arrow to display the annotation on the graph and select Apply to All and click OK. Now, you will see that the signal-to-noise ratio is calculated and displayed above all integrated peaks.